Take a look at this roof here. It can seem pretty daunting, but really this section here is pretty straightforward. It's a full hip roof. These are all the same pitch here. You come around the corner, you calculate these two hips, whatever way you guys are used to doing. You'll notice that the hip and valley come off the two walls and it turns the corner, which means this span is the same as this span, and these hips and this hip are the same as this valley. And in fact, since it comes around the corner, it's the same as this valley. So 1, 2, 3, 4, 5 are all the same length. And then there's this span here, or this is the run, this is the span for this big roof here. You calculate this hip length, and you wonder, if there's a broken hip here, how do I achieve the length of this broken hip? Seems daunting, but if you ran this wall line on through, and you ran this wall line on through, you would have a continuation of that broken hip. It would just be a full hip, just like it is right here, right to the corner of the imaginary corner of the building here. So what does that mean? That means this is interrupted. If this wall line runs on through, if I were to take swing a radius here till I hit the wall line, the length of this valley where it landed would be the corner of the building, which is interesting because then that means the valley plus the broken hip equal the length of the hip. Surely that's the case, you see it? And that would mean this ridge line is the length of this plate line, not including all the deductions, right? Here's another example. You run along here and you have this hip here, which is the same length as this hip, right? These two are the same length as each other because the spans are the same. And then you have this broken hip and this valley, and you have this span here. Well, 1, 2, 3 are all the same length because they're all from the same span here. And this is the same length as this. This plus this equals this. Remember, that means that if you take the valley here and the broken hip here, before deduction, it equals the length of this hip here. Now, if I were to take a caliper and I were to set it right here, swing a line from the valley, a radius like this. See that? And I run this broken hip on through, it become a full hip just like I did on the other side. And you'll see the length of it is the same length as the valley. Once again, that means the broken hip plus the valley equals the full hip. And then how does that help us calculate it? Well, see how I circled this right here? Here it is here. This is the broken hip coming on down, going halfway through the ridge, turning, and going down the valley. And you'll notice since it goes halfway through this ridge and then back, that if this ridge was thicker, then these would have to be further apart. Because if the gap was only this wide, but the hip was wider, it would never make it to the center line. So that means that the gap between these two, now in real life you probably run these on through, have them kiss each other to get a solid connection. But that means that whatever it is, the thickness of the ridge is, it could be a 4x or a 6x, that's how wide your gap would be in every situation. If it was a 4x, the 45 thickness of a 4x is 5 inches. So this would then be, before the math, 2.5 inches, and this would be 2.5 inches. So this already has a deduction on it. When you calculate it, of course, all these have your deductions. It's pretty straightforward figuring these out. So that means the only deduction you have to take off the broken hip is this 2.5 inches if this was a 4x, or 1/16 inches if this was a 2x from this broken hip. That would mean that if you took the full length hip, subtracted the full length valley, that would give you the length of the broken hip. You'd subtract your 2.5 inches and multiply it by your line length ratio, or your secant, or however it is you guys do it, and it will give you the broken hip length. Interesting, right? The traditional way of doing it is taking the big span, subtracting the little span, and that will give you this plate length here. You divide this plate length in half, subtract half the thickness of the upper ridge and half the thickness of the lower ridge, And that would give you the run between the two from this face of ridge to this face of ridge. And that would be the run for the broken hip. Multiply it by your secant line length, or however you guys do it. That would give you the broken hip. Now, to prove that is a little bit complicated, but if you take the big span, which is from outside of wall to outside of wall, subtract the little span, you get this plate length. Now I said divide it in half. Well, if I divide it in half, and I were to bring this line all the way down until it hit that corner, this line here, when it ran up, it would break this run in half. Bring it down, and there it is, half of it. It's a right triangle, and we know mathematically that if the run on the plate, two sides of a right triangle, you calculate the hypotenuse that way. But remember, you have to subtract the thicknesses of the ridge before you do it. So big span minus little span, divided in half, minus half the thickness of the upper ridge and half the thickness of the lower ridge, multiplied by whatever math you use. I use the line length method. It'll give you the broken hip length. It's the same as the one we were doing. That is to say, it's a different method, but it will achieve the same thing. Now, take a look at this. This is a model. Built this a long time ago, used it for roof classes. We built a bigger one, 12 feet long, exactly the same thing, but a big one. The size of the shop I'm in, I think. And you can see that instead of being a broken hip here, you have a supporting hip. Now, structurally, this is really strong. You can put a huge amount of load on this because this hip goes all the way from the upper to the plate, and then it turns the corner and runs into a valley. But if you didn't have this, you'd see that would be a broken hip. These comments would run all the way down without being interrupted. This would be a broken hip. And you can see that it's hard to see because there's no tail here. These are the same length. That is to say, from the center line outside a building to the center of this supporting hip, and from that line down to the outside center line of the building here are identical, right? So that means, and this hip here and this hip here are the same. So it's really easy to see that if you were to subtract this valley from this hip, or in this case from this hip, that would give you the length from the center line up to the ridge. In this case, we're butting the ridge into the two, which we wouldn't do. With a broken hip, we'd run it on through, and we'd have to do the deduction up here. But in this case, it's fine. This is how we would stack it. And this valley, you either leave a valley alone or you raise it and back it. In this case, a V, right? Hip, you either you either drop it down or you have to back it so that all the rafters on that side can plane to the center line. Here's another of the same scenario.